Hey guys, welcome back. So in this episode, we're just going to continue work on our lexer. Now, I've been doing a lot of programming on my own in this so that I can get ahead, so that I can actually, keep making tutorials without like a week in between. So I'm like working on the parser right now, which has allowed me to actually guarantee that my string lexing is like good. I don't know if we'll reach that in this episode, but yeah. I've also done a tiny bit of refactoring. So let me open up our token file. The only thing I changed, if we open it in both, you can see that I flipped the line and the type just to reflect how we have it in the lexer, because I think that just makes more sense. It doesn't really matter, but I think it's just better that it's consistent. While we're in here, we also have to add a few things. So I moved this to up here, and while technically it doesn't need to be a getter, so it doesn't need to be a field, it could be a property, it is best to keep it a field just because we're referencing string, and string can change, so I think it's best to just keep it a field. Anyway, we're going to add two more variables for utility later. Just one called isStringStart, which is false, and isStringEnd. These will be useful, as you'll see soon, because the way we're going to be storing strings, multiline strings, we're going to separate out per line. So for example, a multiline string like this is actually going to make 3 different string tokens. One being, the 3 opening quotes with the new line, the 5 in the new line, and the closing quotes. That will be 3 separate things, and we'll have to parse it all together. And that's useful so that if there's errors, we have access to all 3 of these lines. But also, if we do sort of like the substitution stuff, you'll see how we'll implement that as well. It's going to be in a similar way. So we're not always going to know if the string we're dealing with is the beginning of a total like string thing, or if it's just like an intermediate sort of string. So having these variables attached to our tokens can be super useful. Okay, so we should be able to head back into our lexer, and we'll have to fix our new token thing so that instead of doing line comma type, it should be calling type comma line. Similarly, once we actually implement strings, we're also going to need something else. Knowing when the string ends is going to be really easy, but knowing when it starts isn't going to be very easy, at least the way we do it. So what I'm going to do is I'm just going to add a variable to our lexer itself to know that when we're at a string start. And then let me go down to our new token. It's like all the way at the bottom. We call it so many times. And we have to add like 2 more things. Here's where we're going to pass in whether it's the string end or not. I'm just adding it as a default argument on the end, just for readability's sake. But I also do something else. I also make that other method I forgot about. So let's rename this from new token to new temp token. And the idea is sometimes we want to make a token when there's a warning so that we can display where that warning is happening. But if we do it the normal way, we're going to modify our tokens list. And that's not good. We just want a token that isn't in the list. But of course, as you see here, we add it to the list each time. So what we can do instead is, if we get rid of this, we can just construct the token and return it. But while we're in here, we can set token.isStringEnd equal to isStringEnd. And token.isStringStart equal to @string_start. And then we can just check if we're at the string start, then we can just set it to false. So basically what will happen is when we start making a token, when we start making a string specifically, we'll just set @string_start to true, and then the next token that we make, which we know will be a string, is going to be the one that is at the start. And that way we don't actually have to manage any of that. The lexer will handle it for us. And so that's all that logic, but what we want to now add back is a new token thing. And this is just going to do the new temp token, but add it to the list. So this is actually going to be the same, like, declaration. So I'll just yank that. Come in here, if I, like, paste it. I just need to make this, get rid of that. Okay. Technically, I should do something like that, I guess. It doesn't really matter, though. And similarly, we have to store it, new temp token. Type line is string end. We have to add it like before. And then we return it, because sometimes it's useful to operate off of it. And so now that will add the extra stuff, but it shouldn't break anything that we currently have. And this isn't going to be very useful yet, not until we actually implement making strings. But since the other things are so easy, I think we should probably just go ahead and do them. All right, so we can go down into make token. Let's make punctuators next. And like I said, it's important that the way we do it, you check for a number first, and then you check for a punctuator. Because if the number, you see the number handles the situation right here, where it's like just a period without numbers, like not in a number. So if we go down below all the number logic, we have our make punctuator here. This is actually really simple, and it's really simple because we defined the next string method. Before I had that, it was a lot more complicated. I had to do some crazy loop with essentially a go-to, the closest type thing. So all we have to check is, so specifically our operators in this language that we've designed so far, the most symbols that they will be is 3. The most like wide they will be. For example, that could be a left shift equals. That is going to be 3 symbols. If you have syntax where it's more, you want to add more conditions than 3. And you'd probably want to do it in a better way than this, but it actually wouldn't be that hard. But essentially, just because of how we only have 3 of them, it doesn't really, we don't need a loop. You could do a loop if you wanted to. But all we have to do is, well, if the next string of 3 things is in token.punks, technically, maybe I could do a loop. I'll just try and write it as a loop since you see how easily it is over there. So what we could do is, it would be like a for loop. We loop from, can we do that in Kotlin? Can we go down? 1 to 3 dot reverse or something. If you want to, okay, if you want to implement it as a loop, you can feel free, but I'd rather not spend the next 10 minutes struggling to do something really basic. I'll just implement it as I have. So what we just check is if like the continuous string of 3 symbols next is a punctuator itself, we take it. Otherwise, if the next 2. And so what this means is if you have symbols, file.take 2. So for example, if you implement a double asterisk exponent operation in your language, then this is going to be interpreted as an exponent rather than 2 separate multiplications. And that's why we have to prioritize the biggest width first. Else file.take 1. I've also decided to add an exponent expression into our language, but we don't have to really worry about that yet. But yeah, so we just, if it's 3, we take 3. If it's 2, we take 2. Otherwise, we take 1 because we already know it is a punctuator if it is 1. Do we actually know that? We should. We're checking if it is in punctuator symbols. Actually, I don't even, maybe we do need to check if file.next, I could say next string is 1 because is in token.punks, we take 1. Otherwise, we have to throw an error, because hypothetically, suppose you have, like I'm trying to think of a situation like this, but suppose that you have some operator that's like this, or some operator like this, right? Some crazy thing, just as an example. If you have some crazy operator like this, then a symbol like this would trigger the make punctuator. But the issue is, your language might not have this, and with the code on the right, I'm just assuming that you do, so what we should do is make a, that should probably be an error, so we should just say false.error. And we still actually do have to take the, we do still have to take this, so what we should do is move this condition. I'm so bad at Vim. We should take this condition. Just get rid of that. Otherwise, we do this. And what I actually have to check is, we can say val token is a new token of token.type.punctuator. And then I can just check if token.string is in token.punks. And if it's not, I think if it is, I'll just return. No, because it's a one statement, so I'll just do it this way. I'll say false.error token, like unrecognized punctuator, something like that. Might not be the best way to do it, but I think that's going to catch the extra condition. And we can also make identifiers in a pretty similar way. So what I probably could just gone up here faster. In token.identifier start symbols, because again, identifiers can't start with numbers, but they can have numbers in them. We can just call make identifier, come back down and actually define that. Put it above all the comment stuff. Okay. Now to make an identifier, it's actually really simple. We make a string of file.take. We take these things, and those are token.id sims, identifier symbols. And the only hard part is figuring out the type, because this is also how we're making keywords. Because keywords are just identifiers that your language recognizes. So what we can say is something like the type is equal to if string is in token.keys, then it's token.type.key. Otherwise, it's like token.type.id. You could write this in a lot of ways. I don't really like any of the formatting for this. But yeah, that's essentially it. And then you just make a new token with your conditional type. So those two are really easy to actually implement. Next, we're going to have, I think we should probably do characters, because that will give us a good idea of how we're implementing strings, sort of, I guess. One aspect of them. Unresolved reference make identifier. So I misspelled it the first time. Identifier. Classic. I've done that 100 times. I didn't mean to quit. Okay, we can just head back in. Now, in order to get characters, that's pretty simple. We just have to match, is this thing a single quote? And yeah, since we're matching against specific characters, that's how we would do that. You have to escape it, obviously, in single quotes, and we can say make char. Make char or make... Yeah, I'll say make character to be like consistent, because the others I was kind of full on. And I'll also, while I'm up here, so we don't have to come back, we can also do this to make strings. And then we can go down to the bottom and define them. Alrighty, I'll just quickly add them in. Private fun make character, and private fun make string. Okay, so characters are actually pretty simple, conceptually, right? Like, there's only a handful of things we need to consider. Firstly, characters could be like this, where it's a letter inside of single quotes. They could be a single escape sequence, something like a /n. Or they could also be a Unicode representation. And I'm going to do something pretty similar to Kotlin. There's a lot of escape sequences in C and other languages. I'm only going to really take the ones that Kotlin supports, just because, as far as I'm concerned, those are the only real ones that people use most of the time. And so let's define a pattern to match all of those, similar to what we did last time with numbers. We can create a pattern using a multi-line quote so that we don't have to double every single slash we write. We want the actual quote symbols in here because we want to match the actual quotes for a character. And now we have 3 options, right? Roughly 3 options. There could be a slash followed by a B or a T or an N or an R, a single quote, a double quote, another slash, or a dollar sign. The only unique one here is the dollar sign. That's because we're going to have dollar sign, like the string template dollar sign thing like this. So Kotlin added like a slash dollar sign thing just to escape it. In terms of the character, it doesn't really matter, but it's just a character that our language is going to support, so it should support it in strings and here. Now, it could be a slash followed by one of those things, or it could be a slash followed by a U, in which case we expect hexadecimal digits, and I'm specifically expecting 4 of them. Other languages support like 2 or arbitrary numbers, but I think it just makes the most sense to just have the 4. Or what we could have is something that is not something that's not a slash and not a quote, which could be just anything else, right? Any other symbol. And then we can do to regular expression to make that a pattern. When we call make character, we know that the first thing is a quote, so we should just take that quote. And now we just have some logic. If the next symbol is a slash, or is a quote, I mean, if it's a quote, right? So we took a quote, and now there's another quote. That means it's an empty character. I don't want that to be valid, so I'm just going to take that and say false.error, a new token. Since this is a string char error, I will actually give it the type of char. And then I'll just say empty character literal. Just because I don't want that to be valid, I could make it like the null character or something. But chances are, if you have an empty char, it's by accident, so it's good to tell people that you probably didn't mean to do that. Alright, so now we know that it's not an empty character, so what if the next thing is a slash? Well, if the next symbol is a slash, then we have some sort of escape sequence. And what we need to do is file.take2. So we take the slash and we take whatever the next thing is. And then we can just take until the till the quote ends. So notice this will allow us to take things that aren't actually valid. So for example, we just have a slash in here followed by like a U. The first 2 will be taken, and then we just take until the quote, which means this is valid and this is valid. All of this is valid. But that's why we have the pattern. So we can just take things very generously, and then after we can actually check against our pattern. And if it isn't a slash, then we know it's just one character in there that we need to take, because it's not an escape sequence. Then we have everything inside the character, so if the next thing is not a single quote, then that's a problem. And we should throw false.fail with some new token. You could make it a character again, and I'm just going to say unterminated character literal, meaning we never actually got to, well, either there's too much, right? Like hypothetically, you don't have an ending character, or like there's too many symbols that we're not expecting. So we can just do something like that. Otherwise, if it does work, we can just make a new token, token.type.char, and if the token string does not match our pattern, then we can say false.error with the token, and we can say invalid character literal, because it's just some character that we don't actually want. And this might not be the best way to format this, but I think at least in terms of the logic, it makes total sense how you get here. You just work your way down, right? So that's going to handle all of our characters. And now, actually, it does look like we'll have time. we can make our strings. And so this is going to be a big thing because I'm going to allow multi-line strings and I'm going to allow string templates, as in things like this. If I have a variable called x, I can just plop the value in here. Or if I want a more complicated expression, I can put any expression in here. And the way I'm going to do that is I'm just going to actually use the lexer we have. Instead of making it a subcomponent, I'm just going to sort of utilize what we already are doing. So we call make string. Well, we know that we're at the start of a string, so the next token we make should be the start of the string. Okay, if file.nextString of 3. So we're making a string, and actually, if it's a string of 3 double quotes, well, it's a multi-line string. So we should just do that separately. So we have to define that as well. We're going to have a handful of functions like this. No worries. So that will delegate all that, so we don't have to worry about it. Now we know it's a single string, and we can just take the double quote. And now we can do a loop. I don't want my normal strings to be able to be multi-line, in the sense that I don't want this to be valid. If you want that, you should be using a multi-line string. Therefore, we can loop until file.next is a new line. So we'll loop while it is not a new line. And what we can do is we can take most things, but there's a handful of symbols we don't want to take. We want to pause and deal with separately. If we have a slash, we have some sort of escape symbol, and we want to guarantee that that escape symbol is actually valid. If we have a $sign, that means we have a string template, and we have to handle that. If there's a double quote, that means we're potentially, well, it does mean that we're at the end of the string. And if there's a new line itself, then that's also an issue. So we can use a when expression. When the file.next, the next symbol, if it's a slash, we can call make string escape sequence, which is something we'll be using with the multi-line string as well. Actually, I don't think we will, because multi-line strings don't have escape sequences. It's just interpreted literally, which is why regular expressions become easy with them. If we have $signs, we can make a string template. Gonna have a lot of these methods. Private fun make string template. And that should be the last one of those. And so we don't have to worry about it here. We can just separate out the complexity. If we have a quote, then, well, we're at the end. And we can take the quote, and we can make a new token of type string, token.type.string, and we know that isStringEnd is true. We know that this is the end of a string. And then we can return to leave. And if it's a new line, well, we should just break. And I'm actually curious, the reason I include the new line here is because in the while loop, we're taking characters, right? But the condition of the while loop is only true if the first thing is a new line. So we need to have this in here so that we stop taking before we take a new line. Otherwise, we won't actually know that we were there. And so if it's ever true that we hit a new line, well, that's a problem. It's an unterminated string. So we can just throw a failure. Because especially like unterminated things really should be failures. Because how can you know if the thing after that is actually like valid code, or was it intended to be in the string? So you really just can't continue. And so that's our make string essentially done. We just have to manage how we make escape sequences and how we make templates. So let's get make multi-line string working. It's going to be something similar, but not exactly as complex because we don't care about new lines. We can take the 3 quotes, and then actually, since this takes new lines, we can loop until we're at the end of the file. If the next 3 things are our, triple double quotes, that means we're at the end, and we can take those three, very similar to before. We just make a new string, and we set the end of the string to true, and we return. And so the good thing about doing it this way, suppose you have a string like this, something like this, right? Then this is going to produce one string token, which is going to both be the string end and the string start. It will be the string start because it's the first one created after we call make string, and it will be the string end because it's the last one created. So just by virtue of how we set it up, our tokens will be set up correctly. So that's the exit condition, but otherwise what we want to do is we want to take until, very similar to before, except we don't care about escape sequences. All we care about is $signs and new lines. We care about new lines because, like I said, we're going to split them. We're going to split strings into separate tokens if they go across a new line. So if the next symbol's a new line, then we need to store the line the same way we did when we made new line tokens themselves, because once we say file.take1, the line is going to not refer to the previous anymore, it's going to increment one. So we can now make a new token.type.string and pass in the line. Otherwise, if file.next is a $sign, then what we have to do is make a string template. So the one thing I will say is these multiline strings in Kotlin, which is what we're essentially copying, they're raw strings in the sense that if I type /n, that is not a new line character, that is a slash followed by an n. But it's not raw in the sense that this is not interpreted as string text, which means if you want a $sign, you have to do something like this, which is a little weird. You could design a syntax to allow you to do it otherwise, but I don't think it's like genuous to sort of be like, well, just escape it, because you're not supposed to have escape symbols. Another proposal is to introduce like an actual raw string where you can't use string templates, but personally, I'm not too worried about that, just because string templates are so useful. So if we get to the end of the file, well, that's bad. That means there's an unterminated multi-line string literal. Now we can just implement these two helper methods. And they're actually really simple. Well, because I split that one, I forgot. Yes. Okay, so let's worry about escape sequences first. It's going to be very similar to what we did with characters. We have to make a pattern. Okay, this is going to be essentially exactly the same pattern, except we're not going to allow the like empty character thing. So it's going to be a slash followed by one of our recognized symbols. So it could be a //$sign, or it's a /u followed by exactly 4 hexadecimal symbols. And that's our regular expression pattern. So let's define our escape, which is, we know we have an escape symbol, so let's just take it. It's a slash followed by something. If that thing is a u, right? If escape is literally /u, then we just have to take the next 4 symbols. And if escape matches our pattern, then we can return. Otherwise, if escape does not match our pattern, we can say false.error new token invalid escape sequence. Let me just move this to a new line. Just something like that. So that should, assuming that I didn't design this horribly, which is always possible, that should catch all of our escape sequences and strings. And that way, you don't really have to do this, but it's just a good way to guarantee that if somebody writes a string and there is an escape sequence, you don't just assume it's right, you actually verify it. Now we can make our templates. And there's 2 types of string templates. There are what I call small. So we want to make small string templates. These are things, this is of the form $sign variable name. So these are simple, right? It's just the thing after needs to be an identifier. And then there's the larger ones. There might be like a technical name for these. I'm not sure, but I'm just saying small and large. These are the larger ones where you can have any kind of expression in there, not just an identifier. So I split that logic up into make small and make large string templates. And so let's define our make string template. When file.nextString, when the next two things, if we look at the second one, so we're essentially asking, we're looking at like the thing that is next. The thing following the $, essentially. If it's in token.id start symbols, meaning it's the start of an identifier, then we can make a small string template. If it is a curly brace, then that's the start of a large string template. But otherwise, we can just take the $. Because in Kotlin, for example, if you do $5, that is literally the string, $5. It's only an identifier that you see how it changes color that's interpreted as a string template. Or, of course, curly braces. So we're just doing the exact same thing. We just have our three conditions. String template. So let's come down here. And we can make small ones pretty easily. What we want to do is we want to store the current, whatever the beginning of the string is, we want to store that. So so suppose we have like 1, 2, 3, $X. At this point in time, this new token is going to create a token that has this. So what we want to do next is we want to take 1 to take the $, and then we want to ignore it because we don't actually want that $, in our string at all. So we can take it and ignore it. And this is actually the real reason I'm splitting it up, because we want to separate out the $, from the string. And we can only do that, ignoring that, if we haven't, we're working on like something that isn't already a token. And then what we can do is just say make identifier, and we can return. So because of our loop, right, if we're up here in make string, we're looping. So we know that we're still inside of a string, right? Meaning after we make a string template, we're just going to keep going until the string ends. But we're going to then make another string token. So the way that this is going to look is we're going to have something like this. If you have the string like 5 plus $X is 6, right? This is going to produce 3 tokens. We're going to have a string. I should format it the way that it's going to be printed, with 5 plus space. We're then going to have an identifier, X, and then we're going to have another string after with a space 6. And it's also actually going to have the quote as part of it. We may have to worry about that later. But you see, this is how we're actually managing the logic of this, because we know how to handle identifiers, so we can just parse them exactly the same way as we would otherwise. We don't have to add additional logic to this. We can just use what we already have. And then when we actually like transpile the strings, it's going to be a bit more work, but not really, because we can just transpile the identifier to get its value, and then you could do something like, well, know what type it is, and then you could do like a string.format, %d, comma, X or something. You could transpile it to something like that. And we don't have to worry about that yet, but we're just setting it up so that in the future, we'll be able to do that. Making large string templates. This should be the last thing we have to do, if I remember. It's a bit more work, but hopefully it's not too ridiculous. I'm going to take a sip of water, give everybody a moment to take a breath. Okay. So again, whoops. Also, did I misspell character? Ah, yeah, that's classic. Make character. Alright, now we can go back down to make large string template. Let's implement this. As before, we have to take the beginning of the string and create a token already with it. Now, we know that actually it's not just a $, but it's a $sign with a curly brace, so we have to take both of those, and we have to ignore both of those. Okay. If file.next is the end of a curly brace, well, that means we had something like this, which is an empty string template. And this is, I believe, the first instance of a warning, and it's this reason that I developed the new temp token method. Because we want to take that, but we don't actually want it to be a part of our list, so we can do false.warn new temp token. So we just make a token so that we can pass it to this error, but it's not a part of our list, and we can just say empty string template, because that is a warning. Why would you have an empty string template? It does nothing. I'll warn you about it, but that's totally valid code. It just doesn't do anything. And we can return. Now, we need our loop. While true, so we can just loop forever, we want to ignore spaces and comments, because personally, even if it's a single line string, I want this to be valid. And you see in Kotlin it is. This is valid Kotlin right here. It's not actually complaining, it recognizes it's one expression. So our lexer needs to be smart enough, and it needs to ignore any spaces and comments in there. Part of why I made that a separate method in the first place. And then if file.next is in a list of, if it is the closing symbol, or if it's the end of file symbol, we have to break. And then we can just make token. So essentially what we're doing is, and this is also why I made make token its own method, because the issue was if you called make, if you did, I forget exactly, but it was something along the lines of you need to ignore spaces before you make the token. And after, actually, that's the issue, and after. That's why this is an infinite loop. We're just going to be ignoring spaces and comments, and we're going to be making tokens until we reach the closing thing or the end of file, in which case we break. Val next is nothing, just as a shorthand, so that we know, because once we start taking things, we don't know if this is true anymore, so we should say file.next is end of file. Next is nothing, for example. We can then take the next symbol, we can then ignore it, and then actually if next is nothing, meaning we took nothing, then we want to throw a failure, because it's an unterminated string template. Well, that really went fast. So, as far as I can tell, that's our lexer basically just done. Let me just do a quick scroll through, make sure that everything is here, right? We made characters, punctuators, identifiers, keywords, and numbers, and everything. So in a moment, we'll test this. Yeah, let me just go back up to make token. And we have numbers, punctuators, identifiers, characters, strings, and unrecognized symbols. So let's just run this without changing our test. Everything previously should still work. It should compile. It's all fine. So now let's go into our test so we can actually do some testing. So we have a bunch of numbers in here. I'm just going to get rid of all that. Let's try something like variable x is equal to, or of type in, like just some expression that we want in our language, right? In fact, let me make it of type string. I haven't put these things as keywords, but they should be interpreted as identifiers, and that will be fine. And we should have something like 5 plus 5. 5 plus 6, just so it's different. Let's see what happens if we try and lex this. Recognize symbol, that. And that's totally fine, because we didn't actually add that symbol to our list of tokens and things. So let's try this again. Without that, let's just unrecognized symbol equals, because I didn't actually define equals yet, but let's just do this then. Okay, so you see identifier var, because we never added it to our list of keywords, identifier x, And then we have the start of a string here. This is the start, followed by a number 5 plus 6, end of string, new line, end of file. And that's exactly what that is. Let's try doing something like this. See if those spaces are ignored correctly. And now there's a new line here, but otherwise it's totally fine. Let's try making this empty. Interesting. So it works, but we didn't get a warning. So let's try and figure out why that is. Let's go back into our lexer. It's either going to be in the lexer or the false. But it shouldn't be in the false. Actually, it might be, right? Because we changed it so that when our stage finishes, if errors.size is 0, we return. Or, yeah, so if there are no errors, we do nothing. So let's go back into here, our app. So what's happening, I'm guessing, we're making, you see here, we're printing our faults only if there's actually a failure. So we're not printing our warnings yet. So what I want to do is, like, right at the end, actually, we just have to check if our false.warnings.size is greater than 0, we just want to print it out. Because otherwise we weren't actually getting any warnings. So that should solve that. And there we go. We have a warning, empty string template. We passed in a token, which is this. You could, try and make it better than that, but I think that's totally fine for the error message. We have a token here that is pointed to, that we can see, but it's not in our list because we made it a temp token instead. And you see right here, we just have the string start and the string end. We can't see that the tokens actually have those properties yet, but once we actually go into our parser, it should be fine. I think, let's just do a bit more testing since we also found that. It's always good to do a little bit of testing, and if you can unit test, that's even better. What other operators? We have like a plus, a minus, a star. Double operators, like a shift. And let's do a shift and a less than and see how it interprets it. Because it's going to interpret left shift less than. It should. Unrecognized punctuator. But that's also totally valid. Because, like, this context makes no sense, right? You're never going to see this in your language. So, is this going to be okay then, or is this a problem? Based on how I did it. Because the reason this is happening, if I just come over here and go down here, we can look. The reason is, this first one's being triggered. Wait, why is this happening? It's just because none of them are being... File.3 is in token.punks. Well, it isn't. That's actually curious. Maybe I inverted my condition or something. But the other ones are working. Yep, we can just go down. So, our next string 3 is not going to be a punctuator. 2 isn't going to be a punctuator. 1, well, 2 would be, right? Because we'd have a left shift. So it should take 2, and then it should make a token. And if the string is not in the list, if the string is not in here, then that's an error. And let's take a look at our punctuator lists. So our punctuators, it has the left shift. It doesn't have a less than, though. Perfect. Yes, I didn't even notice. But also... Oh, that's just a warning. Wait. Lexing error, unrecognized punctuator. It's also not formatting it pretty well, so we could probably fix that as well. And you notice the error... No, it's fine that it's an error, which is why it's not a failure, which is why we can actually see it in here. Unrecognized punctuator. So it shows it up here, but it tells you it's not valid. So that's totally fine. It's not unrecognizing the whole thing, it's just saying this individual one isn't valid. Because it isn't, because we didn't add it to our list. Perfect. So what I just want to do now is format this. This is happening because reasons. It's going to be in the toString. And we have to go out, go to false, somewhere in the toString here. Because we're doing warnings.join_to_string new line, but that doesn't actually end it in a new line. Errors.join_to_string new line. And the issue is, if there's nothing, I don't want a new line. So I think I have to make this a bit less condensed. Honestly, if you're all set in this video, feel free to just click off now. This is probably just going to be some live developing, so it's going to go a bit slow. But essentially, all you have to do is figure out how to format this properly, and all you have to do is check if the warnings are not empty, then join them to string and then end them with a new line. So let's see, if I go join to string, you have a prefix, a postfix, a limit. There's tons of stuff in here. My very dumb monkey brain just wants to do something along the lines of if warnings.size is greater than 0. Something like that. Yeah, and I'll just make like a val warn new line is equal to if warnings is greater than 0, then we set to a new line, otherwise empty. Just something like this. And then we also would need... Yeah, I see now. That's why I put the new line here, because I thought it was the failure problem, but that's not the issue. It's that they all need to end in a new line. And it looks like the error... No, it's not the error that does, it's the whole thing probably. Or new line is... I bet I can do this. This is probably the stupidest way to do this, but it should work. I mean, it should work, right? But it's just going to be really stupid. And then I can get rid of this. This dot. So I could probably change this, since we're just adding something after, to like a dot plus. And we can just add a new line after. And now it actually prints correctly. Let's get a failure in there as well. And let's try and do it in this order so that we get all three of them. No, I don't want to go in here. Test file, let's see. So at the end here, we need some sort of failure. Let's just start a string and not end it. Failure unterminated string literal. And so you see all three of these are formatted nicely. There's two new lines here, probably because I ended it in a new line because I didn't realize that. Well, when I'm printing the faults, it doesn't, but I am saying print line. Because it's always going to end in a new line. Except the failure shouldn't. Because we're adding the new line to the end of the failure if it exists. Yeah, but that should just be a single new line. And then we're doing print line. So where's the third one coming from? Oh, probably from like Gradle or something. It doesn't really matter, because this isn't even how we're going to be running this most of the time. It's also really weird. You notice it is printing in the wrong spot as well, because this is supposed to be the building thing and then build successful. It doesn't really matter, but it should be further down. That's a weird thing. That's really strange. So if I wonder how I can even like change that. Just by waiting? It doesn't really matter though. So I think overall this is just an improvement. And it's not going to look like this when you use the software, because you're not going to be building it every time. You're just going to be running it. And how am I actually running it? C.bash. I'm just doing Gradle run. Okay. real w run dash dash args. I'll just type it by hand because I don't trust it. Test.test/file.c. And if I run it manually, it's still sort of, the issue is, again, you're still not going to run it this way because it's just by Gradle. But overall, though, this is really good progress. I think our lexer, like I said, our lexer's done. I may have to tweak some of the formatting, but that's going to be not too big of a deal. Let me go back up into the test just so that it's not failing. I don't want our parser to start off badly, so I'll just leave this empty. Let's try to run this empty. Doesn't matter. Perfect. So that's going to be the end of this episode, guys. I hope that my lexer makes sense to you, and I hope you think it's a reasonable design. I will also mention, if you are trying to make like a legitimate language that is supposed to be competitive and fast and efficient, you should look into other parsers that already exist, because we are making it by scratch, mostly because it's kind of fun and it's a great way to learn how it works. But if your goal is to make something legitimate, you'd want to use software that already exists that does all of this for us. It would auto make tokens and make an abstract syntax tree for you. And then there's a lot of other software that can even transpile for you. So I recommend looking into that. Maybe once I'm done with this, I can look into that myself and then take you along the journey with me, because I do not have experience in that arena. But for now, we're just going to keep trekking on and keep making this by hand. So in the next episode, we should be able to start designing our nodes and our parser. I'll see you guys then.